Hello everyone, this is Singh and I'm back with another dive deep in which we will be talking about consistent hashing at scale. So this is the discussion from booking.com architecture from the engineering blog of booking.com, which talks about how the customer review system is scaled. Okay, so whenever a customer books particular property from booking.com, he or she has an option so that after the stay is completed, they can review the properties. Okay, like how was the stay or any kind of review which is added. So what we want to do is we want to store that reviews, we want to store those reviews into our system so that if the queries are raised, that if other users who are interested to book those properties, if they are looking for the properties, and then if they are looking for the feedback or the reviews, they are able to view that. Okay, so this is our discussion today, and this is based on the blog from booking.com, which you can check it out. I will share the video link, blog link in the video description. But before that, we have to do two things. First thing is, if you are not subscriber of channel MsDeep Singh, consider subscribing. I keep on making this kind of videos in which we try to discuss the analysis or like the reasons behind the decisions which are made in the large scale architectures. Okay, so this is one of the example in which we are talking about how the customer reviews are stored and then they are scaled, and there is something about consistent hashing in our discussion video today. Okay, so this is the first thing, you have to subscribe to the channel MsDeep Singh. If you enjoy this video or if you learn something from this video, like the video and share with your friends. Another thing is, there is a great book, awesome book, which is written by me with co-author Jayant Kumar. It's out now. You can read it now. You can order it. You can read it on multiple platforms. You can get it on the Amazon Kindle. You can also buy it. You can also read it on O'Reilly platform. So the book is completed. Great news. And you can read the book. Okay, and there is also a chapter, in one of the chapter is hotel reservation system. Okay, which talks about what are the different decisions, or like how you are coming up with the architecture for uh, the hotel reservation system. Okay, how the properties are booked, how the properties are onboarded, how these reviews are stored, how the dynamic pricing works. So there are a lot of things, and finally we also talk about how this architecture is deployed on AWS cloud. So that's why system design on AWS. So this is the cover. Okay, this is the front page and this is the back page. We have some awesome reviews, and forward is written by Swami. He is the VP of AI and data at AWS. Okay, so great resource to learn system design concepts as well as how you understand that decision making, or the how you do the dive deep when you do or make those decisions while choosing particular technology, while doing those pros and cons, how you understand the problem statement, all those things. You will learn a lot of things. It's a book, it's a big book which talks about all those things. Okay, so get your copy now. Coming back to our discussion, what is our discussion? We are trying to scale customer review system from booking.com. So what are the things? First of all, there are system requirements that we have to consider what we are trying to design. Okay, so what are the requirements? Horizontal scaling to serve increasing before. So the the idea behind today's video is that we have already deployed this customer review system, right? So you have some review system. Okay, this review system, and then it stores this to database. Okay, now we are trying to scale it. Okay, that's our heading as well, consistent hashing at scale. Okay, so our requirement is we want to ensure horizontal scaling to serve increasing customer review traffic. Okay, understood. Another thing is withstand AZ failures. If you're not aware of AZ basically means availability zone. So consider in context of AWS, right? AWS has multiple regions. Okay, let's say Mumbai region or Hyderabad region. Okay, or let's say in US you have North Virginia region. Okay, Oregon region. So these are the multiple regions on which you can choose to deploy your technology. Inside these regions as well, there are availability zones. Okay, these are also physically separated data centers. Okay, so you have physically separated data centers, but they are in the same region. Okay, so these are also connected together so that you have a faster connectivity over the resources which are deployed across the edges. Okay, what you want to ensure is if this edge goes down, your system is still working. So what you are trying to ensure, the data the data which you are keeping is deployed or stored at multiple places. You are storing the primary copy here, let's say you are storing the replicas as well. So if one AZ goes down, you are still able to serve the traffic of both reads and write. Okay, so we are clear with the system requirements. Now to design, what what is the design for this system requirements? Support horizontal data partitioning. Now again, the discussion will go into the consistent hashing part. Before the consistent hashing part, okay, if I talk about the general data storage, like let's say if you are, let's think on how you will store the data. Okay, so assume that you are using any of the relational DB architecture. Okay, and right now it's designed to store the data on a single machine. There are definitely replicas in place, but there is a single instance which has all the data kept. Okay, there are replicas which also has the data to fasten your read queries, but there is a single instance of DB which keeps all the data. Okay, so in our current architecture is, let's say this is writer primary instance and there are multiple replicas, and all the replicas store the same data as writer. Okay, these are used for read queries, and this is writer is used for read and write. Okay, great. So this is our first architecture. Now if you're trying to scale it out, let's say you are dividing the data based on any of the partitioning strategies. Okay, there are multiple partitioning strategies which can be used. Okay, horizontal partitioning, vertical partitioning, and range based. I don't think if there is something called vertical based partitioning. So horizontal based partitioning is there, then there is range based partitioning. Okay, so you have to figure out how your data is partitioned. That also you can read in the book. What are the different strategies for partitioning? So based on that strategy, you are dividing the data into multiple instances. Okay, so instead of all the data being kept on this single writer instance, now the data is stored at multiple instances. Okay, this is what we mean by horizontal scaling. You are separating the data into multiple instances. Great, so you have multiple instances now on which the data is kept. Now let's say, consider a scenario how you will figure out that on which instance the data resides. Okay, so the architecture is clear till now that you are storing the data at multiple places. Okay, so imagine in this way, like you have three instances. So this is instance db1, this is db2, and this is your db3. Okay, these are the three instances where you are storing the data. Now you have to figure out, you have to have some routing layer. Okay, this is, let's say, your application routing service. Okay, or not routing service, your review system. Okay, and in review system you have one component called routing. Now the responsibility of routing module is to figure out which DB instance I have to hit to write the data or to read the data. So assume in this case, the partitioning which I have done is based on the property ID. What do I mean by property ID? On which property the user has stayed, and then she is a person is reviewing that property. Okay, so based on that property ID, you figure out that which DB instance I have to go to. So the simple strategy is you take a modulo by the number of servers. So in this case, number of servers is 3. So depending on that, you will know that which DB instance I have to go to write the data or to read the data. Okay, so this is the simple strategy which you can use. Great. Now the problem arises. So this is the simple hashing. Okay, simple hashing mechanism. Now the problem arises. What if a instance goes down? What if this instance goes down? So this modulo operation will change to 2. Or let's say you are increasing the number of instances because you want that horizontal scaling capability. So you are increasing the number of instances. Now if you are increasing the number of instances, again this number n will change. If this number n changes, then your hashing function change, and this routing system or the routing layer will not work as expected. You will have to update the logic somehow, or you will have to move the data somehow, so that you know that okay, this is the new location for my data. Okay, so multiple problems. What are the problems? On increasing decreasing number of partitions, the function change for the where the data needs to be stored. This we understood with the help of example, because this modulo function is changing. Data needs to be moved in whole. Okay, so what you have to do is the data has to be moved because this function, hashing function, has changed. Shutdown of one AZ while the data is redistributed. Until a resharding is completed, the coordinator service will not be able to figure out where the request should be routed. This coordinator service is basically your routing component, which figures out where the data has to be routed. So this is the general users. You have coordinator service. Coordinator service is your uh, component in your review system. Okay, then it goes to the different shards. When I said these are the DB, multiple DB instances, multiple DB shards on which the data is stored. Okay, so we came up with one solution. We tried to divide the data. Okay, we identified there are some problems with that architecture, so we have to resolve that problems. Okay, so what are the improvements which you can do? Improvements are done with the help of consistent hashing. So consistent hashing is a algorithm, you can say, or a design strategy which helps. Okay, so the major problem was whenever an instance or DB instance, DB shard is added or removed, you have to move the data in whole. Okay, so that complete resharding takes place. The data whatever it was on this node will we have to stored on some other node, will have to be served by some other node. Okay, so let's say this db2, okay, it has the data range from 1000 to 2000. So this data, some data has to be served by this, some data has to be served, so entire data has to be moved. Okay, so how consistent hashing helps now? Consistent hashing helps as in, so it's a ring basically. Okay, so the all the storage servers, if you see here, we had 3 servers, right? So all these 3 servers, or like whatever the number of servers we have, the diagram which I have attached here has 4 servers in place. And this picture I have taken from my previous video which I created on the consistent hashing basically, and this the same example which I took here. So that video is still relevant. Okay, you can go check out that video as well to understand consistent hashing. That is in Hindi. Today we are discussing in English. Okay, but the idea is pretty same. So you have 4 servers in place and you have your range divided into 0 to 1000. Okay, so how you have placed the servers? You have first server placed at 0, second server placed at 500, third server placed at 750, third server placed at 750, and then your fourth server is placed at number 900. Okay, so how will you store the data? How will you store the data? Now, once your servers are placed, you can also place the servers depending on some hex function. Some one example is that you take the IP of the server and pass it to your hash function, and depending on whatever location you get, you assign that location to that server. Okay, now once you have defined that value range, okay, once you have defined that space, okay, value space, in that space you have to decide like where the data has to be stored. Now let's say a new review came in for a property ID. Okay, some string. Okay, property ID 1. So for this property ID, when you took the hash of it, the value was 233. Now you have to decide where I have to store this data. Okay, so you check in this ring, do I have a server at 233? Let's say this is the 233. Do I have a server at this place in the ring? There is no server. So what you do, you move in the clockwise direction. You move in the clockwise direction, and the first place where you find the server, you store the data at that server. Okay, so in this case, there is no server at place 233. You moved clockwise. The next server which comes into the ring is server 500. So you store the data at this server. So for property ID 1, the new review is stored at location in the server at location 500. Okay, so this is the general uh, philosophy or the algorithm which you are using to store the data. Okay, so great. Now let's say a new server is added. Okay, let's say, because what we are trying to achieve here is if a new server is added or removed, we want to reduce the amount of data which is reshuffled or retransferred to another shards. Okay, so in here, the remapping is only done for the k by n keys. K is number of keys and n is number of servers. Okay, so the number of keys which are stored on that server, so only the remapping is done only for those servers if they are placed in ring in such a way. Okay, so let's say you are adding this new server here. Okay, let's say you are adding this new server here. So the mapping is only done for the keys between 900 and 1000. Okay, so some of the keys will be transferred to here and some of the keys from here will be transferred to here. Okay, so let's say take that example of let's say my value space is, let's say this is 950. Okay, this server is placed as 950. Okay, now let's say my new review came. Okay, it was 931. Okay, it was 931. Now if it was 931, you earlier you went into this location, there was no server at 931 and this key was stored at server 1000. Okay, now but since there is a new server, this 931 should be stored at 950. So this is the key which is reshuffled. Okay, but if let's say the key was 960, so it was stored at 1000 and still remain at 1000. So this is what I mean by reshuffling or retransferring of keys to another servers to balance the keys out. Now there is one problem. Okay, this problem can arise both in consistent hashing ring as well as your normal sequence ring, what you can say. Okay, in which you are maintaining these servers. One problem which can arise is hotspot issues. Okay, let's say there are multiple keys which are stored on this singular server. Okay, now in that case the problem is that this particular DB instance becomes a hotspot. What I mean by hotspot is, it means that particular server is accessed uh, multiple times, as in like kind of overloaded, or like it is hit more times than it is actually expected out of it. Okay, let's say the supported load for the server is only 500 requests per minute, but you are hitting it with 1000 requests per minute. Okay, so this is what I mean by hotspot, because you have stored more data there. Okay, so to avoid that there are few things which you can do. First thing is, you can introduce server replica so that your requests are distributed. Okay, you can serve your read requests through this server. Okay, another thing is, you can place virtual nodes. When I say place virtual nodes, this placing of virtual nodes we discussed in our Dynamo series. We created 3 videos where we discussed Dynamo architecture, the paper of 2007 from Dynamo, not DynamoDB, Dynamo, which talks about this consistent hashing and then placing virtual nodes. So the idea is simple. Okay, the idea is simple. So you have your physical nodes fixed. Okay, you have your 4 physical nodes. So you have your virtual nodes in place. When I say virtual nodes, they are mapped to a physical node only. Okay, they are mapped to a physical node only, but they are assumed to be placed here. Okay, so and these virtual nodes are mapped to these nodes. Okay, and they can be mapped to the nodes depending on how your depending on the load on that particular node. Okay, on that physical node. Okay, so this is how you can redistribute the keys between the physical nodes. So these are 2 ways in which you can avoid overload or the hot partition issue on a particular physical nodes. Now coming back to this, was the extra discussion which we had. Okay, this is not in the blog, what consistent hashing is, how the data is stored and all those things. Okay, uh, so the blog starts with consistent hashing is helpful. This is the picture which is taken from the blog. Okay, this is how you done this is how you store the data earlier. Then you came up with consistency. Now consistent hashing, now how this consistent hashing helps. So there is one property, what is this monotonicity. Okay, so this property says, it's a property of consistent hashing. Okay, this property says the data can only be transferred from read about monotonic functions if you have not heard about this till now. Okay, so read about monotonic functions, you will understand the idea here. So the data can only be transferred from old shards to new shards during an ongoing resharding operation. Okay, so any redistributed key will either stay on its current shard or will be moved to newly provisioned hardware. You might get confused. Let me explain it a little bit with help of example. Okay, here we have example. So keys that are part of n shard scheme, old scheme, should also be a lot of English. Let's understand with the help of diagram. So earlier, let's say you have number of shards as 8. Okay, new in the new scheme you have number of shards as 12. So when I say keys that are part of n shard scheme, so n is your 8, should also be part of n plus m shard scheme. So n plus m is your 12. Okay, so you have 8 plus 4. So keys, whatever keys which you have, so whatever data which you are stored in this scheme should also be present in this scheme. Okay, so we are clear with this. Now after that, now whenever a new shards are introduced, okay, whenever a new shards are introduced, they are not known to the coordinator unless the coordinators are informed about them. Okay, so the coordinators are only informed. The coordinator is basically your routing service. Okay, so the routing service is only informed about the new shards once the data is fully moved. Okay, whatever the data was needed to move, it is fully moved, and the new set of shards is able to, or like ready to serve the traffic. Okay, so what you are trying to do here is, coordinator are not, yeah, okay, coordinator only route the request to all shards. So you have added the new shards, but right now the requests are only routed or like served by the older shards. Okay, so once the data is fully moved, when I say fully moved, it means whatever data or like whatever keys has to be remapped to these new shards. Okay, once that is done, some coordinators, the routing service component, okay, some coordinators inside it is informed about the new scheme, and other coordinators also became aware too. This gossip protocol is not mentioned there, so I assume that they might be using the gossip protocol so that once some of the coordinators are informed, they will also inform the other coordinators as well. Okay, since they are in sync with each other. And this also helps in if there are any issues. Let's say you have definitely have not let's say you definitely have metrics in place how these new shards are performing, so you can also always switch back from this scheme to this scheme if there are any issues. Now after confidence, you are sure that and then like this, there can be gradual migration. Okay, let's say you have this number of shards, then you increase the number of shards. There can be gradual traffic increase, that yeah, 10% traffic is served, then 20% traffic is served. Once you have complete confidence, then you update the old shards to stop loading keys and were reassigned. So whatever keys which were new, which were reassigned to the newer shards, they can be removed or they can be stopped be serving from the older shards. Okay, so this is what are the learnings. Okay, not this is all. So what are the learnings? Observability, which means we have metrics in place so that this particular, okay, how can you say that yeah, I have gained the confidence now and now a new shard scheme can be used. Okay, this you can do via the observability part. You have proper metrics in place, you have proper logs, you have proper alarms. If anything goes wrong, you have system in place, you have mechanism in place to identify those issues and fix those issues. Okay, fallbacks in place you should have. If something goes wrong, you have observability, and if something goes wrong, you have fallbacks in place so that you can handle those. Because if something can get wrong, something can go wrong, will go wrong. Okay, so this is the famous quote from the Amazon design docs. If something can go wrong, will go wrong. So you always have to ensure that you have fallbacks in place to handle those failures in your system. So this is all about today's video. I hope you understood what consistent hashing is, how it was used by Booking.com architectures to scale their review system. And since we are at the end of the video, if you have still not subscribed to the channel MsDeep Singh, consider subscribing and get this awesome book in your toolkit to understand how you design the system, what are the different concepts, how you design system, how you will understand different AWS services which are there in the different domains. So get this book, and if you are still not sure if you should get this book, what you can do is you can get a free trial on O'Reilly platform for 10 days and use that trial to check out some of the chapters, and then you will get, I'm pretty sure you will gain a confidence that yeah, this is a great book, and then you can buy the entire version. So I hope I was able to convince you. But yeah, I will meet you again in new set of discussion videos in which we will be diving deep into similar large scale system architectures. Till then, stay safe. Tata. Bye bye.